In this video, we'll discuss another component in the Spring Framework. The components that supports aspect-oriented programming, or AOP. There's lots of new terminology in AOP. In fact, a large part of learning AOP is to learn the terminology. So here's the first one, concern. In software development, we can usually divide the functions of an application into groups, where the functions in each group are related to each other and serve a general purpose. For example, for an online retail application, we may divide the functions into user functions that deal with user accounts, like registering a new account, editing account information, recovering password, and so on. And we can have product functions that deal with adding products, changing prices, searching based on product description, and so on. And we could have other functions that deal with placing, fulfilling, and tracking orders. The general purpose of each function group is called a concern. For example, user management is a concern. Product and order management are also concerns. Most concerns can be implemented as a module of the application, and this modularization is quite important because it breaks down a large, complex application into smaller pieces that can be developed, tested, and changed relatively independently. And that makes building the application a whole lot easier. Unfortunately, some concerns cannot be easily put into their own modules, like logging, transaction management, and security. Virtually every method needs some logging. Almost every database access needs transaction management, and terrible things will happen if you forget security in some places. This type of concerns are called cross-cutting concerns, as they are needed everywhere and there's no easy way to modularize them like other concerns. So what's so bad about cross-cutting concerns? Well, here's an example of transaction management. You probably didn't do this when you write JDBC code in your homework. But this is something you are supposed to do when you write commercial software. In particular, you should catch any SQL exception and perform a rollback of the transaction if an exception happens. However, rollback itself may raise exceptions, so you need to catch that and do something with it too. Now imagine that you have to do this everywhere you access the database. That's lots of ugly boilerplate code scattered all over the application. It's tedious to write and difficult to maintain because if you want to make any changes, you have to change lots of different places and it's quite easy to miss something. So what is aspect-oriented programming? It's a way to separate out cross-cutting concern code into their own modules called aspects. Let's first see an example of aspect-oriented programming in action. Then we'll dig a little deeper and discuss the underlying mechanism. So, as always, we'll start with an interface. I have an interface here called logged task, and this interface defines three methods: do something else, and hello. This is my first implementation of log task 1. And in this implementation, I have logging messages in do something and in do something else, but not hello. You may not be familiar with logging, the log levels, info, warn, error, and so on. And if that's the case, don't worry about it. As you'll see in a moment, for our purpose, they are not too different from system.out.print. They are just printing some messages to the console. So this is my first implementation of the interface, and this is my second implementation. And in this implementation, the actual methods themselves are pretty much the same, except that this one doesn't have any logging statements. So generally speaking, when we write code, we prefer this type of code. Looks nice and clean and clear what the methods do. But in practice, we would need to write this type of code because logging is important for our application. Now, here I have another class contains a main method. In this class, I declare a task which is of the interface log task type, and there's a getter and setter. And if you remember from our Spring Bean configuration video, you can kind of see where this is going. So we are going to use Spring to inject log task 1 and log task 2 here, and then we are going to call their methods, do something else, hello, and see the output. So this is a Bean configuration file, and this is the main class having the main method, and we are injecting log task 1 to it. And let's run the code. So if we run it, we can see that it's running the methods from log task 1. So this is the output of the first method, a log message at the beginning, and then some printout, and the log message afterwards. And then this is the output of the second method, again, a log message at the beginning, some printout, and then a message at the end. And then this is the output of the third method, no log message, just a printout. And no surprise here. Now let's change this so that instead of log task 1, we inject log task 2 into it, and we run this code again, and this is the output. And if we look at log task 2 again, no surprise here, this is the output of the first method, output of the second method, output of the third method. So this is what we normally would see. If we have some log messages, if we have some logging statements, it will do the logging. The code is better, but looks somewhat messier, and the main function of the code is not as clearly readable. And this one looks more concise, easier to read, but it's missing the logging messages. So with aspect-oriented programming, maybe we can get the best of both worlds, and indeed we can. So I'm going to inject this into log test. So this bean is called log task 2 with advice. We don't know what advice is yet, but let's run it first. So we're going to run this. And we notice that all of a sudden, this log task 2 gets a bunch of logging messages. So this is the output of the first method, logging message at the beginning and the end. This is the output of the second method, output of the third method. Now, you may be thinking, is this really log task 2, right? Because there's nothing here, and are you trying to trick me or something, using some other classes and so on? So I'm going to prove to you. So I'm going to change this line here. Instead of saying says hello, I'll just change it to hi CS5220 class. And if we run this again, it will say hi CS5220 class, and it's indeed calling this method. However, we are still getting the logging messages. In other words, without writing any logging statements like log task 1, we get the logging anyway, and we can keep our main code clean and simple and readable. And that seems to be quite nice. So how does this thing work? It seems all a little magical. And but if you think about it, we can actually implement something like this ourselves. So here's the problem we are trying to solve. We're given a class. Let's call the class foo. And this class has a method, and let's call it bar. And what we want to do is, whenever this method bar is called, we want to execute some code before the method call, and then some code after the method call. So if you think about it, this is basically what we had here, right? So this is a method call, this is a method call, and before the method call, we print out some logging message, and after the method call, we printed out some logging message. So the restriction here is, of course, we cannot change the class itself by editing the method. So how do we do this? It turns out that we already learned not one, but two ways to do this from our lower division programming classes. The first way is to create a subclass of foo, and we can override the method bar in the subclass. In the subclass bar method, we can add whatever additional code we want to execute, and after the method call, we can then add whatever method we want to execute without changing the original method. And there's actually a second way to do it. And in this case, we can create a class that holds a reference to a foo object. This class is usually called a wrapper class. Again, in this class, we implement a new bar method that calls the original bar method, but with the additional code. So this is, in fact, the basic underlying mechanism for AOP in Spring. Just create a subclass or a wrapper class and replace the original method with a method with the additional code. So once we understand this, it's easy to understand these AOP terms. Target refers to the original class, and in our example, it will be foo. This would be the target class. And proxy is the class with the additional code. In our example, it will be either foo1 or foo2. Proxy interface is an interface that both the target class and the proxy class should implement. Having this interface allows us to replace a target class object with a proxy class object. And last but not least, advice is the additional code we want to execute. So now, knowing the terminology, it's easy to understand what's going on with the bean configurations. So we injected log task 2 with advice, and this is the bean definition for that bean. And to make things a little bit clear, I have put the code here. So we have a bean called log task 2. This, remember, is the original code without any logging statements. And here, first of all, notice the class of this bean. Notice that it's called ProxyFactoryBean. Now, we don't know exactly what this thing does, but just by looking at the name, you can tell that this is something that creates proxies. So notice that although Conceptually, it's easy to say, just create a subclass or just create a wrapper class. But we don't really want to manually write this code ourselves. Instead, Spring provides something called ProxyFactoryBean, basically automatically create those proxy classes for us. So that's great. Now, in order for Spring to create those proxy classes for us, we do need to tell this proxy factory certain things. For example, we need to tell that, hey, the target class and the proxy class both need to implement this interface called logTask, which is this interface. And the target is this bean, which is, of course, the original logtask2 code. And then the advice, or in other words, the additional code is in this bean called logging advice, which is this class. So if we look at the logging advice class, we can see that it has two methods, one called before and one called after returning. And inside before, we can see the code that's executed before the method invocation, and inside after returning, we can see the logging statement executed after the method invocation. We'll come back to this class a little bit later, but you get the idea that this is the additional code that executed before method invocation, and then we can add additional code after the method is invoked. And then more terminology. So join point is a point in the execution of the application where the advice can be plugged in. For example, before and or after method invocation, before and or after field access, and so on. A point cut is a predicate that determines join points. For example, its method name begins with do something could be a point cut to determine which methods should get the additional code. Introduction is to add new methods and or fields to existing classes, and the weaving refers to when introduction happens, which could be during compilation or when the class is loaded or during runtime. Here's some information about Spring AOP using just standard JDK without any additional AOP tools like AspectJ compiler. In Spring, advices are written in Java, and point cuts are defined in XML or using annotations. Spring only supports method join points, which means additional code can only be added when a method invocation happens. For example, you cannot add code before or after a field access. In Spring, aspects are woven in during runtime, and the good thing about that is you don't need any special compiler or class loader to have AOP work. And Spring also has an additional term called advisor, which basically is a combination of advice and point cuts. There are 4 advice types in Spring: around, before, after, and through. As the name says, they allow us to execute additional code when certain event happens. For example, before a method invocation, after a method invocation, both before and after, or when a method throws an exception. So let's quickly look at one of those interfaces. So this is the interface of the before advice, or method before advice, meaning that if you want to execute some code before a method is invoked, you put your additional code in a class that implements this interface. Notice that this interface only has one method called before, and it gives you a representation of the method, the arguments of the method, and the original target object. And here, if you look at our logging advice, you can see that this class implement method before advice by implementing this before method. And exactly what method class provides, or the API of method, that's not really important. For our purpose, just understand that basically whatever happens inside here will get plugged in before a method is invoked. Similarly, the after returning advice also only has one method to implement called after returning, and you can put your additional code in here, and this code will be executed after a method is invoked. So this is an example of using both before and after advice, and we can achieve the same thing using a so-called around advice, basically meaning you only need to implement one method, and it allows you to do both before and after. So this is, in fact, what it looks like if we want to replace logging advice, which implements both before and after, with something implementing the around advice, just one method. Again, the API of method invocation is not really important. Just know that it represents a method, and you can invoke that method by calling invocation.proceed. So in this case, you can add whatever code you want to add before, and then you call invocation.proceed to execute the method, and then you add whatever code you want to add after. And the Bean configuration looks like this. So first, logging interceptor is this around advice with the additional code. And here we are using a so-called advisor. And as we just mentioned, advisor in Spring combines advice, which is this one, with a point cut. And the point cut here basically says that apply this advice if the method name matches do something followed by anything. As you can imagine, there could be other ways to match method names, which we won't get into. But if you need, for example, you could use a regular expression map to match names and so on. So once we have our advisor, just like what we did before, we need to create a proxy using the ProxyFactoryBean, and this proxy will be a combination of the original class, the target, and the advice class, which contains the additional code. And we can try this. So instead of log pass2 with advice, I'm going to do log pass2 with advisor. So if we run this, we can see that now the first method in log pass2 gets the additional code. The second method also gets the additional logging message. The third method, however, doesn't get anything. And that, of course, is because we have a point cut here that says only a method that starts with do something will get the additional code. So if we want, we can change that, and we can change it to say only if the method is called hello will get the additional code. And if we run this again, we can see that only the hello method gets the additional logging messages, and do something and do something else methods don't. Just like dependency injection, you can use annotations for AOP, but we won't get into that. If you are interested, please check out the Spring documentation. By and large, dependency injection is something that you do all the time when you use Spring Framework. AOP, on the other hand, you don't use it directly that often. It's in fact fairly rare that you have to write advices yourself. However, understanding AOP is important because many components of the Spring Framework, like transaction management and security in particular, uses AOP extensively. So we do need to understand the AOP concepts, but for our purpose, we won't spend as much time explaining AOP stuff comparing to dependency injection stuff. So with that said, this is a very brief introduction to AOP and AOP in Spring. So for us, the important thing is to understand the concepts of AOP, the terminology, the underlying mechanism of how it works. And once we understand the basics, it's much easier to understand and use certain Spring features like decorative transaction management and security. And before we wrap up, remember one more thing. AOP is very, very useful, but at the same time, it's a somewhat dangerous technique because advice code is separated from the regular code and is introduced behind the scene. Debugging becomes a lot more difficult because human brains are just not very good at imagining code or analyzing logic that the eyes cannot see. So be very careful if you have to write AOP code yourself.